Okay. Hey guys, this is Paras. I am a software engineer at Dgraph, and I will be talking about fuzzing today, specifically continuous fuzzing with Go. So my agenda for today is to go over what is fuzzing and some of the terminology that is used in fuzzing. I will then talk about continuous fuzzing and its benefits, and then move on to talk about two tools. One of them is Gophers. It's a fuzzer for Go programming language, and the other one is Fuzzit. It's a SaaS platform which allows you to do fuzzing as a service. I will then go through a step-by-step guide on how I was able to implement continuous fuzzing at Dgraph using the tools that I just mentioned, Gophers and Fuzzit. I will then talk about some best practices and then follow it up with some references and give my contact for any questions that people might have. So many of you might have heard about fuzzing, and what I generally understand is that people think of fuzzing as randomized testing. This is only partially true. So let me give you a framework or a definition of fuzzing. So fuzzing is an automated black box testing methodology. All it does is it blasts input to a software that you want to test and looks for crashes or leaks or any errors that your software might report. One thing to note is that the bugs that are found or the crashes that are found by fuzzing are generally never a false positive, which means they are always a bug and it must or should be fixed. A related term to fuzzing is fuzzers. Fuzzers are nothing but a test driver. They are the ones that generate the inputs and sends it over to your software under test. And there are two main types of fuzzers: generation based and mutation based. Mutation based are more common. Generation based are the ones where the inputs that are sent to the software are generated from scratch, whereas in the mutation based, there is a seed corpus. I will define seed corpus next, but basically think of it as a set of initial inputs that are manually fed, and then the fuzzer takes over and starts mutating upon those. So I talked about corpus. Corpus is a set of inputs. There is something called a seed corpus, which is your initial set of valid inputs that you manually feed to the fuzzer. And then over time, the fuzzer will basically grow your corpus with more valid, more mutated inputs. So the combination of the seed corpus and the mutated inputs becomes your current corpus or just corpus. As I mentioned, the main goal of fuzzing is to find bugs and report crashes and leaks in your software. But a good byproduct of fuzzing is the corpus itself. And we should always save it periodically and use it for regression testing, which I will talk about next. Some applications where fuzzing is a prime candidate: any program or a software that follows a structured pattern and takes its input in a particular fashion. Think of RFCs, IETF standards, networking protocols, finite state machines, or any formal grammar. These are all the softwares that implement these expect their inputs in a structured manner, and these are all prime candidates for fuzzing. In real world, you will see query languages, compilers, networking protocols, parsers, markup languages, where fuzzing is generally used. In case of Dgraph, we use fuzzing for our query language. We are actually a graph database, and we have a query language called GraphQL plus minus, and that's where we are using the fuzzing technique. Okay. So coming to continuous fuzzing, as the name suggests, continuous fuzzing is simply adding this fuzzing testing methodology into your CI and CD pipeline. The goal being that every PR will go through a fuzzing step when it's submitted. Some benefits of fuzzing is: one, fuzzing is really cheap and it is automatable. Except for the initial seed corpus, there is little to no human intervention required once it is set up and running. Fuzzing allows you to catch regressions. I think of it as two types of regressions or two types of issues that it can find. One is the synchronous local regression, which will block your PR. So what this means is that the corpus that you have up until now will be used to test the package that you're testing. And this is generally really, really fast. It's not mutating. It's not doing any fuzzing. It's just taking the corpus and running it against your package. So this is synchronous and your PR will be blocked if there is any issues. The second kind of regression is what I call as asynchronous regression or long-running fuzzing job. So this is something that should not block your PR, because this is, technically speaking, we want this fuzzing job to run forever. And whenever it finds crashes or leaks, we want to be notified. And these are, again, bugs that need to be fixed. So those are two types of regressions. The other benefit, which I touched upon earlier, is that the corpus grows over time. You literally don't have to do anything. Once the fuzzing is set up, it will start from the initial seed corpus inputs and mutate upon those inputs and add it to your current corpus over time. Just for example, at Dgraph, we started with 207 inputs in our seed, and as of today, it is about 3,700. And this is all because of fuzzing over the last several months. The last benefit, again, is when you want to, let's say, try different implementations of your software or a parser, or you have made some bug fixes, or you're introducing new features, continuous fuzzing helps there as well. So let me talk about Gophers. It's a fuzzer. It's a very well-known fuzzer for co-programming languages. As I mentioned earlier, fuzzers are either generation-based or mutation-based. Gophers is a mutation-based one. And because it is mutation-based, it needs an initial seed corpus, which is manually fed. And one thing to note is that the seed corpus, or especially for Gophers, your seed should contain a diversity of inputs instead of a large number of inputs. So try to have your seed corpus encompass a lot of different types of input that covers many different areas of the software that you're trying to test versus just similar inputs being fed into the seed. Gophers is also coverage driven, which means it will mutate an input if it increases your coverage and it is a valid input, and it will decrease the priority of the input if it is not a valid input or it does not increase coverage. There are two ways to use GoFuzz. I will touch upon both of these. The first one is directly using the GoFuzz to fuzz your programs. And the other one is where GoFuzz is used to create an archive or a library file, which is then used with libfuzzer. Libfuzzer is a fuzzing technique for fuzzing libraries under test. So we convert our package into a library and the libfuzzer is used with that. The reason this exists is because sometimes you don't want to share your code or you want to fuzz on a third-party server, which is what we are doing in our case, although our code is not proprietary in any ways. We are open source. So the second tool that I wanted to talk about was Fuzzit, Fuzzing as a Service. It's basically a SaaS platform that makes available one or more CPUs per account. And what it does is it simply allows you to do fuzzing 24/7 on their servers. Remember, I talked about asynchronous jobs. This is what it really provides. It also provides local regression jobs. So when you say, Fuzzit, do a local regression job, what Fuzzit does is it simply downloads the latest corpus and then runs your package against it. It has good reporting. It has a very nice user interface where you can see the crashes that happened, and you will also get alerts and notifications. The corpus obviously is downloadable and the entire service is authenticated. So you will receive an API key which can be used to unlock the features. Just a tidbit, Fuzzit was actually acquired by GitLab just last week. Okay, so now that we know about fuzzing and what GoFuzz and Fuzzit does, so these are the steps that I took for implementing continuous fuzzing, which uses the GoFuzz and the Fuzzit service into our CI/CD platform. The first one is you need to write a fuzz function. So identify the package, the Go package that you want to fuzz test, and within the package somewhere you want to write this function, which is of type, which takes as input a slice of bytes and returns an integer. The input is basically your seed corpus and any other mutated input that the fuzzer will generate, and it'll call this function with that input. And what you want to do in this fuzz function is convert the input into a format that your software needs. In some cases it could be as is, or in some cases you need to encode it in some different way, and then call the main entry point of your software. This function should return 1 if the software did not see any issues or any errors, which tells the fuzzer that this is a valid input, and it will also use this input, increase the priority of this input for future mutation. 0 otherwise, if it is either something that does not increase the coverage or it results in some errors, then in that case you should return a 0. I will quickly show you what the fuzz function looks for us. So for Dgraph, we were fuzzing the GQL parser, and our fuzz function is very simple. All we are doing is we are taking the input, sending it to our parse function, which basically takes this input. This input is a query that is used to query the database. And if there is no error, we return 1, which basically means it's an interesting input. Otherwise, we just return normal. Okay, so at this point, technically speaking, you are good to use your GoFuzz tool. So you can basically build a zip of the package that you're trying to fuzz with this command. And then once you have the zip file, you basically run Gophers on it. This is how you would run it.
Could you increase the font size, please? Thanks.
Okay, better?
Yeah, it is better. Thanks.
Okay, yeah, so the code that is, or the command that is highlighted, it basically uses the Gofuzz to start fuzzing. And yeah, that's it. It basically starts fuzzing, but this is a long running job. And this is one way of using Gofuzz, but that's not the way we are using at Dgraph, because we wanted to use it with Fuzzit and use it in a continuous manner. So that was step one. Step two, as you might expect, you need to manually feed the corpus, the initial seed corpus. In case of Dgraph, we had 207 such corpus. This is where every application might have different ways of gathering these inputs. Some ideas could include, scraping your unit tests, for example, for finding the inputs. So once you gather these inputs, put them in a folder, and all these inputs go one file per input. And this is what is used by GoFuzz to start fuzzing. The next step is Fuzzit. So at this time, what you should do is create an account on Fuzzit. It's a free service, and obtain your API key. And then you create a target on Fuzzit. Think of target as nothing but a segregation of different packages that you might want to fuzz, or different software that you might want to fuzz. So it's just a segregation. And we will use this target for fuzzing in our case, continuous fuzzing in our case. So I have a target already set up. It's called parser fuzz target, for lack of creativity. So once we have the Fuzzit account and the seed corpus is set up and the fuzz function is written, what I did was I created a script called fuzzit.sh. What this script does is it simply does all the steps that is needed to run the Fuzzit. Let me again go to my code to show you what the script does. I won't go into all the details, but basically all it's doing is it's downloading GoFuzz, doing a GoFuzz build with the libfuzzer option, because that's the option we want for continuous fuzzing. And then it basically uses this clang compiler to spit out a target. The step two is basically download the Fuzzit CLI, create a target if it does not exist. So in our case, this will be skipped. And finally, it creates a job, which could be either a fuzzing job or a local regression job. And that's it. And then it's clear. So as I mentioned, you can call this script with either local regression as an option or fuzzing as an option. As mentioned here, local regression runs it locally against the corpus. It is not fuzzing. It is just running the corpus against the target. And fuzzing is a long running job. It is asynchronous. So once we have the script, the final step is to go into your CI platform. In our case, it was TeamCity, and add a new step in your CI/CD pipeline. As you can see on the screen, the new step in our case basically all it did was it called this fuzzit.sh script 2 times, one for the fuzzing job and one for the local regression job. And that's about it. So at this point, what will happen is that every PR that is submitted against our repository will kick off the CI. And one of the steps within the CI is this fuzzing step, which will do the local regression, which will download the corpus and run it against the target. And it will also do the long running fuzzing job. This is it. That's all you need to do to incorporate continuous fuzzing in your CI/CD platform or pipeline. Some best practices while I was doing this: fuzzing is cheap, so you should fuzz often. Specifically, look for opportunities that are programs that take structured inputs. As I mentioned earlier, it could be anything like a parser or a query language, and any such thing. Because fuzzing reports bugs which are generally never false positive, it's always a good idea to look at the bugs, reproduce them, and fix them as soon as you can. Corpus, again, it's a gold mine, and you should save it periodically. And finally, the seed inputs, think of quality over quantity. And as you add new features, add new seed inputs into your seed corpus also. So that's about it. I have a blog which basically goes into more details about all of this, and there are some more ideas about how we can improve upon the continuous fuzzing. For example, we can make it conditional and some of those things. I'm available on LinkedIn, Twitter, and here is my email if you guys have any questions. And we also have a forum which is really very active. So feel free to ask any questions there as well. So not just me, but anyone from our engineering team or the larger team will answer your questions. By the way, we are hiring, so reach out if you are looking looking for new opportunities. Finally, I just wanted to talk about a new product. It's what we call as /GraphQL. It's a managed cloud service offering by Dgraph, which we just announced it about a week ago. It uses GraphQL API for all its interactions. So any full stack or front end engineers here, they will find this really, really appealing. And on its backend, it uses the Dgraph's flagship database, which is distributed, horizontally scalable, and it's a graph database. So give it a test drive. You also get 10,000 credits. These credits are used when you use the service for querying your data. And that's it. Thank you, guys. Let's
Thanks a
open
lot,
it up for questions.
Paras. So I have allowed participants to unmute themselves if they have any questions. So please feel free to unmute and ask questions.
Sure. And if anybody, I'll share the slides with the organizer. So if anybody wants, they can get in touch with the organizer.
Sure, thanks.
Yeah, I have one question. Can you hear me?
Yes, I can.
Hi, Paras. Thanks for the demo. The question is, why is it that Fuzzit never gives you false positive? Like, what makes it so?
So the idea is that the fuzz function that you write, you have full control over it, and you will return 1 or 0 from that function. And the GoFuzz, so Fuzzit is basically a wrapper on GoFuzz in its simplest form. So when it reports a crash, it gives you the input that caused the crash. It gives you the output of what it saw in case of a crash. And this input, assuming your software is deterministic, this input is the one that caused the crash. So if you run it again, you are expected to see the crash again.
Okay.
Did that answer your question?
So basically, it is a binary to say whether a crash happened or not, right?
Yeah. So crash is just one class of errors that it looks for. You can look for memory leaks. You can look for errors. That all depends on how you write your fuzz function. And there are different strategies on how you write it. In our case, it was very simple. If there is an error,
Right.
It's not interesting. If there is no error, that is interesting.
Right. So basically, you're saying that it catches an error, and the reason for that error can never be why it caught that error can never be false positive. Is what you're trying to say, correct?
That's correct. Basically, it will basically dump the input that caused that error, and
Yes.
generally speaking, they are never false positive.
Yeah, which is generally the case even when you try to capture some logs from, let's say, from any infrastructure or something like observability, right? So if you try to catch a log, pretty much the device will never send a error message if there is none, correct? So it's pretty much like that, I guess. Okay, thank you.
Ankit, I see your hand raised. Please feel free.
Yeah.
We can hear you, but your volume is very low.
Is it better?
Yeah, very good.
Yeah. Okay. So very interesting talk, Paras, actually, because I'm very new to like fuzzing. So one confusion that I had in my mind is like, how does this compare to something like a unit test? Like, pardon me if it is like a stupid question, but like this was confusing me.
So actually, that's a good question. So what unit test does is that you write the unit test and you run it, and you look for any regressions there. So it's basically not smart enough to generate other inputs or other unit tests for you. So if I had to draw a parallel, what Fuzzit does or what fuzzing does is that you give it some inputs, think of them as equivalent of your unit test, but it generates thousands more unit tests, or in this case, thousands of more inputs for you. So it basically, that's where the beauty of fuzzing comes in, right? I mean, you just give it some inputs and then it will automatically mutate upon your input to generate more valid inputs, which is equivalent to your unit tests, if you will.
I see. So that's then I can relate it to something like a query language, because you cannot cover cover it entirely using unit tests. So like fuzzing does make sense there.
Yes.
So
Yes,
another,
definitely.
Yeah. So another thing that was going in my mind was like one thing that you mentioned was that Gophers works with coverage. But if you are like really looking at it, you are just giving it a function which is calling your parse function, right? So how is it able to figure out the coverage, and how is it able to mutate over that to increase the coverage?
Yeah. So if you look at the steps when I mentioned how it uses how to use GoFuzz, so the first step is called GoFuzz build, and what it does is that it actually rewrites some parts of your program or the package to be able to do coverage.
So it probably
So
adds
what
some
it does
hooks or
under the hood
something.
is beyond my understanding also, but
I see.
basically what it from what I understand, it rewrites some aspects of your program, and then that's how it's able to figure out whether there is increased coverage or not for every input.
I see. Just the last corollary question to the last one. That so what you said that Gophers, like in general, it tries to increase the coverage by increasing the number, increasing the like mutating the corpus such that it increases the coverage, right? And you also mentioned that like corpus is a gold mine. Like this is one thing that I heard. But what about if you like refactor your code? Like then the coverage would change, I guess. And will the corpus still be that useful, or just wanted to know that?
Yeah, if you refactor, but your general I mentioned very early on that fuzzing is actually a black box testing. Yes, it will muck around with the coverage, especially with Gophers if you refactor your code a lot. But still, the corpus that you have are valid inputs. So as long as you did not change your, for example, the query language, that corpus is still valid. I mean, those are valid inputs that you can use against your refactored code to see what regressions that it might have introduced. Yes, you can start with that corpus as the new seed corpus to start with, so that way Gophers can start from there. So it doesn't have to rely on the old corpus if you have refactored. Does that make sense?
Yeah. Thanks for explaining it very nicely. Thank you.
Sure.
Ravar, you have a question? You can go next.
Yeah, hi, thank you. Thanks, Paras, for a very nice presentation. So I have two questions. So first is, as part of first testing, do you even cover credential scanning, like secrets or let's say something like AWS credentials?
Not at this time. In our case, we are trying to fuzz our query language, and our inputs are the queries that we get from our clients, like the database clients, and that's what we wanted to fuzz. So we didn't do it in our case.
Okay. So the next question is, so something you mentioned about running an asynchronous job as part of your CI/CD for your first testing, right? So like you mentioned that the asynchronous job, it doesn't affect the PR or it doesn't block it. So let's say the PR is merged to the latest code and that it's moved to the production. And what if you analyze that there are a couple of failed tests as part of your asynchronous job once it completes, right? So how do you roll back the changes, or so how do you maintain it from there?
Yeah. So first of all, the asynchronous job never ends. It's a continuously running job. And one thing I did mention is that every new PR stops the previous job but starts a new one. So and the new one will pick up from where the previous one left off. And to answer your question about what if the asynchronous job finds some crashes, so what it does, it gives you the timestamp, it gives you the input that caused the crash, it gives you what the output is, and given that, the best you can do is look at the PRs that went in at that time and try to pinpoint. I mean, there is no I don't know if you can correlate one-to-one to the PR, although that's a good question that I should look at myself also. But my strategy generally has been to look at when that crash happened and look at the PRs that went in that day.
Okay, sounds good. Thank you.
Girish, you have a question? Rangasamy will again come back to you after this.
I was basically asking, I've heard of property-based testing. This seems similar, I felt. I just wanted to check if it's same or is it different?
Hey, can you repeat your question? I missed the first part.
There's something called property-based testing. Is it similar to property-based testing?
I'm not sure about what is property-based.
Paras, I can take it if you don't mind.
Sure, go ahead.
Yeah, so it is slightly similar, but the goals are actually different. So in property-based testing, you are defining certain controlled criteria, but then saying that any value that satisfies this criteria is going to be input. Rather than working with some static input, you're saying that I can generate data on runtime, but it should satisfy a particular invariant. But fuzzing is more broader than that. Fuzzing is out there to find those cases which you haven't tested for, which you can't really write tests for, and you start off with some valid seed input and then mangle that input in various ways possible, so that you can find out those corner cases which you can't really test for, or it is too much of an effort for you to manually think of those cases and so on. So the scopes are very different. some of the ways in which the coverage is leveraged to find out or guide the inputs is common. There are some similar strategies there, but the goals and the approach is very different. So are the inputs and the length of test, the time it takes to test, and all. They are vastly different. Sorry if this was a very general answer, but if you have a specific question, I can dig a little more, Girish, or maybe I'm happy to get in touch with you later also to explain more things.
Sure. Actually, yeah, it was helpful for me to gauge the
Yeah,
difference.
we'll just go over the other people who have questions and maybe I'll get in touch with you. Yeah, Rangaswamy, you had one more question.
Yeah. So basically, I see that Fuzzit supports a lot of the language like Swift, Rust, and everything. So I just want to know if we can just use Gophers instead of Fuzzit. What is the value add that Fuzzit brings in to the table? Is it like a framework? Because it's just a wrapper at the end of the day, right?
Yeah. So the value that it brings is that one is that you don't have to spin up a server where you can do your fuzzing 24/7. I mean, Fuzzit takes care of that for you, and it also has a good reporting or a dashboard which shows you when a crash happened or when a memory leak happened or any such thing. And lastly, obviously, it is authenticated service, so you can basically do it in an authenticated manner in the cloud.
Right, perfect. So basically, you're saying that since the core of it is still Gophers, and I can still use Gophers in my code instead of going for Fuzzit, as long as I take care of my reporting and other stuff. So
yeah, and also the Fuzzit makes it easy to integrate with CI, right? They have several templates, and I mean, my script was basically based off of one of the templates. So that's basically their value add.
And the template gives you what options like?
It's the script that I mentioned. It basically allows you to run local regression jobs and long-running fuzzing jobs on their servers, asynchronous ones.
Okay, so the idea is kind of load sharing, correct? I want to have my separate testing environment separated from actual production or development code. So that may be a critical point in Fuzzit. Is that, am I right?
Yes, and also let's say you have a very busy repository, like you have hundreds of PRs going in a day. You need something that is elastic and scalable, horizontally scalable up and down, right? Because every PR is going to do fuzzing, so you want that many jobs running.
Paras, but if I'm already having my code on GitHub, wouldn't I already have done a quality check in the first place? Why would I do it again? The moment it hits the GitHub production code, I would have already done my check, right? Hello? Hello? Can you hear me?
Yeah, we could hear you. It looks like I'm not
Paras
sure.
has dropped, I guess.
Yeah.
Hey, I'm back. Sorry, I got disconnected.
Oh, okay. Sorry, I'll just repeat myself. So what I was saying was, if your code is already hitting your Git repository, right? So you would have already done your quality check and all the other error handling. So why would you want to do your Fuzzit again?
Sorry, come again. So you're saying that your code is already doing the error checking, but it's only doing the error checking. Sorry, go ahead.
Yeah. Go ahead. Sorry.
So yeah, I mean, your question is why should we fuzz or why should we do continuous fuzzing?
Why should we do continuous fuzzing on the Git? Rather do it before it hits the Git.
You can do it before it hits Git, but it's a long running job. So how much are you going to wait?
What do you mean?
So fuzzing is you can literally run it 24/7, right? It's just going to keep trying different inputs and report crashes to you, right?
Yeah, right.
So and you want to be able to trigger that when a PR goes onto your GitHub repository, right?
Correct.
So that's why it makes sense to just incorporate it into your CI, where it does not block your PR, but it also kicks off a fuzzing job asynchronously, while also doing a local regression with the current corpus to at least do the check where your current PR did not break anything against the corpus.
Okay. Kind of answered it. Thanks, Paras.
Sure, thank you.
Aditya?
Okay. So Paras, I want to add to the Ankit point that means how it is differentiate. We differentiate this with the unit testing. So means in unit testing, we don't actually use the actual DB services. We mock it. But what's the scenario in this? We will be using actual DB services, or we'll mock in this case of fuzzing?
No, it depends on your application. So in our case, if we are a database. So what we wanted to fuzz was our query language, and the input for a query language is the query, which is nothing but a string, right? And there is only so many unit tests that we can write manually, and it is not going to intelligently generate more unit tests for us given a set of inputs, right, or a set of queries. And that's where fuzzing comes in, right? I showed it in one of the slides where we went from 200 manual inputs or the seed corpus to 3,700 without lifting a finger, right? And that's the benefit of fuzzing. We are now at 3,700 inputs that we can run against our parser to make sure nothing is broken, and that would take forever for us to do it manually, right, or do it with unit tests.
Okay, so you said it's a black box testing. So whatever we need to test, so say this my example. So if we have DB also and we have an application also, so that DB and application both will be a part of that black box.
That is something that you as the application developer will have to decide where and what packages or what areas of your application you want to fuzz. You could fuzz at the application level, treating the application as the black box, or you could fuzz at a lower level where it connects to the database and fuzz at that level if you control the database or you are a database company.
Okay.
I think the differentiation here was that I think Aditya was talking about how to test the application, but what Paras is talking about is the application itself is the database here.
Yes,
So
that's
what
correct.
you're actually testing is not mocking the database and testing your application level, but it's actually testing the query parser of the database itself.
Yeah, that is correct. I think that clarification was.
So we can define the testing whether it's an application level or whether it's on the some module level.
Yeah.
So
I mean, think about the Go compiler itself, right? Its input is the program itself, which is nothing but a big file or a string, right? And you can actually fuzz that and see how the compiler works.
One thing also comes into picture is that one thing Paras mentioned in the beginning is like there is a specific set of software with which you want to fuzz. Like it probably won't work with every kind of application.
Yes.
Like if your application just has like 3-4 inputs possible, then you would just be able to write the unit tests. Probably don't need fuzzing. I guess.
Yeah, that's correct. I mean, so basically all you want to do is make sure that your whatever is the code that parses your input is rock solid, and it follows some some grammar or networking protocol, or it takes input from the wire, right? Then in that case you want to be able to fuzz to make sure that there are no code paths that are not executed, and uncover any bugs that you might not be able to find otherwise.
Thanks so much.
Milap?
So something follow up on that part is would during fuzzing would we be able to write assertions, or it's just that the fuzzing would run?
No, you can write your own assertions. You can panic. You can do all sorts of things. Gophers is smart enough to figure out what happened, and it will increase or decrease the priority of that input based on what happened with that input.
Okay. And my next question is, would fuzzing be also useful for load testing? Like if you want to check how the method behaves when it's accessed concurrently?
No, this one is mostly serial. It just serially blasts input, which are mutated versions of your seed inputs in a serial fashion. So no, I don't think it's good candidate for load testing.
Okay.
Cool. Anyone has any other questions? Guess not. So if you have more questions, I think you could reach Paras directly. He has shared his contacts on the last slide. So thanks a lot, Paras. It was a very nice talk. Also very evident from the number of questions asked. So thanks again. Also thanks again for making slides last minute. So to people who don't know, I made a request to Paras one day before, and he was gracious enough to talk and also make some slides for this talk. So thanks again.